Differentiating using product rule is what we are going to see now. We have seen how we can use the chain rule. Now, we are going to see the functions that we can't handle using chain rule. Now, product rule, it helps us to differentiate when you have a product of two functions and then they want you to get their first derivative. We are using that product rule. So this is the technique that helps us to differentiate a product of two functions. So we consider functions v of x. This is the function of x, and also u is a function of x. This means v is a function of x, and u is a function of x. So, to get the y, the x, because all these two are products of, are functions of x. So, to get the y, the x, we say we get v times the derivative of u with respect to x, then plus u times the derivative of v with respect to x, as we are going to see. So, it should be a product before you use this. Look at this, differentiate the following. One, they give you y equal to this. This is a function of x, and this is a function of x. It can be a function of t or t. So they are in the y and the t. So don't get confused. So since the product, what I do, I let this be u, and I let this be a v. As simple as that. So what we do, n1, you let this be u, let this be v. So you let my u be 3x minus 2, and you can let your v be 4 minus 3x. You see v the function of x and u the function of x. So now to get our, you see that we need the u dx, we also need the v dx. We have u, we have v already, as you see there. So we need the u dx now. So my du dx here is going to give me, when you show this, you get a 3. When you differentiate this with respect to x, the v dx, we get a negative 3. When you differentiate this. So after that, now you come and substitute in our formula. So we need the y dx. Our y dx, we say is the same as v du dx, then plus u dv dx. If I substitute, my v is here as 4 minus 3x, then times du dx. Our du dx is here as 3. Then plus our u is here as 3x minus a 2. Now into the v dx. So the v dx, which is a negative 3. So that's it. Or some people have it as u, the v, they start with this, then you end with this. That's the sum you can interchange. So when you open the brackets, this times this, I get 4 minus this times this, I get 9x. Then plus this times this times this, I get minus 9x. This times this, I get plus 6. So when you add, you see 6 plus this, I get 18. 6 plus 4, I get 18, then minus negative 9, and this I get negative 18x. And that will be our y dx, which you can easily factorize out 18. When you factorize out 18, we get 1 minus x. As simple as that. Factorizing out 18 because it's common. So that's how we apply. When you come to this, you see it's a product of two functions, this and this. So see that our v, you see that this one, the root is the same as a half. So you say now, let this one be our u. So if you have our u be x squared minus 1, then here we let our v be 1 plus x plus 1, x plus 1 power a half. So, when you share this, get our du dx, which will be 2x, because this one is going to be 0. Now here we are going to apply the idea of chain rule. How do we differentiate this? Because we have a power and we have a function and a power. So the v dx is going to be the same. You lower the power, maintain the bracket. This is the power by 1. Then subtract a half, and then subtract 1. I get negative a half. So this is negative a half. Now differentiate the bracket. When you differentiate this, you get 1 The differentiate one we get at 0. And so this one is going to give us now 1 over 2 into x plus 1 power negative a half. So now our dy dx, which is equal to now b just substitute into the formula. So now if I substitute, I have my b as power half into du dx, which is 2x, then plus u, which is then dv dx. My dv dx is here as a half into x plus 1 power negative a half. Now this one, you go further to simplify. So this will be the same as 2x into x plus 1 power half, then plus, this will be, now this is negative, I push it down, I have half x squared minus 1 over, when now this 2 is here, when this one goes down, it becomes now a positive. So x plus 1 power a half when it goes down like this. So here, you always simplify, I cross multiply like that, up and down. So see, this times this, I will get 4x into this times this. You start, they are the same bases, so I will add the powers. So I will get a half plus a half, which will be a 1. What I'm doing, in simple terms, I'm applying the properties of indices. So I'm going to be adding now x plus 1, then plus, this times this we have x squared minus 1, the whole over, this time it is 2 into x plus 1 power a half. So what we have applied here, we know that always, we know that our x plus 1 power half into x plus 1 power half the same. We have that the same base, we add these powers. So we have x plus 1, now a half plus a half, which will be x plus 1 power 1. So that's what we multiply this and this will be adding this. This 2 has multiplied this to get 4. When we add these powers, that's what we have. That's why we are adding this. There. So now, we can go on to open these brackets and see. So this times this, we shall be having 4x squared. Then this times this, we have plus 4x. Then plus x squared minus 1, the whole over 2 into x plus 1 power a half. Can you simplify? When you see this and this, you get 5 x squared minus, plus 4 x, then minus 1, the whole over x plus 1 power half. Remember, I'm trying to 2. So can we factorize this? Let us see if we can factorize this. So two numbers are multiplied to negative 5, then I add, I get 4x. Let me do it here. So I have 5x squared plus 4x minus 1. This will be, two numbers are multiplied to negative 5. Those can be a 5, then a 1. When I multiply them, I get negative. Because this is negative, it means that the signs should be different. So, of course, this is positive, so the biggest is negative. So, this you can write it as 5x squared. Now, where there is this, I put this 5x minus x minus 1, which will be 5x is common into here x plus 1, here negative 1 is common, with x plus 1, which you can write as 5x minus 1 into x plus 1. So you can factorize that into that. So the whole of this now is going to be, we factorize that, we are going to be adding now 5x minus 1 into x plus 1. The whole over 2 into into x plus 1 power a half. Now we have to simplify this further. This and this are the same. We say if you divide the numbers of the same base, you subtract the powers. This will be 5 x minus 1. Then you get x plus 1 into 1 now minus this a half. And you see that will give us 5x minus 1 into x plus 1 power negative a half, which you can push down and you get the answer as 5x minus 1 the whole over x plus 1 power a half. And so that will be our derivative. Well, now we come to this. So now here we don't have the product yet. What happens if we don't have the product yet? We create that product ourselves. How are we going to create that product? Create the product. Well, whenever we are dividing, we take this half. So you know that this one is power half. Like this, it's power half. So if you take it half, we have now x plus 1 into 4x plus 3 power a half. But because it's on the product, I take this up. So my y will be now x plus 1 into 4x plus 3. When I take it up, it becomes negative a half. So instead, let this one be my u, which is x plus 1, and this one will be my v, which is 4x plus 3 power negative a half. So from here, I already the x is going to be 1. So here I already v. The x is going to be, you lower this, maintain the bracket, then reduce this by 1, then you differentiate the bracket, differentiate this, you get 4. So when you simplify this, shall be adding this half multiplies this 4, get negative 2 into 4x by 3 by negative 3 over 2. So you have seen how we use the chain rule. So from there, now our dy, the x will be, I'm not going to quote, but I'm just going to say it's here. Our v, from here, our v is 4x plus 3 by negative a half into du dx. Du dx is 1, then plus our u, which is x plus 1. Now, we get the v dx. Our v dx is negative 2 into 4x plus 3 by negative 3 over 2. So now we just simplify this and see what we get. So this will be the same as 4x plus 3 by negative a half. Then we multiply this here, shall be having minus 2 into x plus 1. Now we push this. We can push this down and we have it as 4x plus 3. Now this power will be 3 over 2. And we cross multiply here. So we are going to get 4x plus 3. So if we cross multiply, we shall be adding now the powers. We shall add the powers, negative a half plus 3 over 2. And we get this that we shall get a 1. Then minus 2x minus 2, we open brackets there, all over 4x plus 3 over 2. And this simplify, this will be 4x minus 2x, you get 2x, then 3 minus 2, you get plus 1, all over 4x plus 3 into 3 over 2. Simplify that. So that's how we are going to get our dy dx. But there is a simple technique that I'm going to take you through immediately here. So that's how we use the formula. Well, now the simple technique is, you look at number 1. Number 1 was, like we said, technique in the chain rule. Also this one, you are going to be having a simple technique, as you will see. Now, idea here, if you want to do it in one step, you say, fix this, differentiate this, then plus fix this, then differentiate this. So that's how we use that technique. So here, you see the function of x and y. So my y, the x will be, I fix this, you fix it, 3x minus, do not under it. Now differentiate this. When differentiate this, we get negative 3. Then plus. Now you fix this other time. Now you fix this. So you then fix this. I get 4 minus 3x. Now differentiate the other bracket, which is 3. And you see it's the step we have here. Then try to expand that. You'll be adding negative 9x plus 6 plus 12 minus 9x, which will give you negative, this will give you 18 minus 18x, which you can easily remove 18 minus x, and you'll be having your answer like that. I think you see it's the answer we put here. Then this one, the same idea. So let me try this C out. This was A. Let me try for you C, and you will be able to complete it. So my C is that my y was from this step x plus 1, and then 4x plus 3 power negative half. So that's it, our y, x, and c. So our y, the x will be, fix this, differentiate this. When you differentiate this idea, I will be having lower the power, negative half, times, we maintain the bracket, reduce the power by 1, then differentiate the bracket, differentiate this bracket, you get 4, then plus. Now fix this, 4x plus 3, and negative half. Now differentiate this, so differentiate this, you get 1. Now we can go to simplify. I think you see that it's the step we have here. You see this is here, then the all of this is here. The x is here. When you multiply this and this, that's when we get this negative 2. And then you can go on simplify. So that's the technique also in one step. I wish you well.